Over the last week or so, I've been playing with a new acquisition, which is a Pisound module. I've in fact got two of them because well, let me first of all say what they are. A Pisound is a board which has a audio input and output two-channel and a MIDI in and out, which is designed to plug into a Raspberry Pi and bring these facilities to it. And as such, it's quite exciting to anybody who wants to use a Pi for audio work. And in particular, it works quite nicely with Sonic Pi. I've got it with version 3 here, but it will work with previous versions as well. The reason I've got two is that there are various other features of this board, and we're going to exploit some of them here. And one is that it comes with a program called modep, which is a virtual modular system of synthesizers and various processors for audio, and these are displayed on a browser screen, which you can see running here. I'll make it a bit bigger later on, and this shows one of these modules and the wires. These are the two audio outputs coming from it, and this is a MIDI input coming into it, and this is the Pisound concerned. This has got a Raspberry Pi in it, and you can see the MIDI input coming in here, and that's actually coming from the other Pisound, which is running Sonic Pi. So Sonic Pi is going to produce some MIDI, which is sent down this cable to this Pisound, which is running modep, and some of the virtual synthesizers in this are going to produce some audio, and that's going to be fed back down this black cable back into the inputs socket of the audio card here. And Sonic Pi 3 has got new features, one of which is live audio, where it can receive audio while it's playing a program and mix it into what it's doing. And so we'll see that in operation. The other things in this are simply two white leads going off to 5-volt power supplies, and there is a little modular amplifier here which feeds the speakers, which I normally listen to, down this red cable coming from the output of the Pisound, which is running Sonic Pi. The other thing each of these can do is it can act as an access point, and this one here is acting as an access point and is actually supplying the IP address of my Mac here, and also of the two Pisounds, and also of my iPad. This is the screen picture of it at the moment, which is live, and that is running a TouchOSC interface, which I've designed and called Sonic Pi Jukebox. Notice it says Sonic Pi Jukebox, not Sonic Pi 3 Jukebox, because it will run equally well with Sonic Pi earlier versions, and it will, although of course you won't be able to use play MIDI files with that, because that's not incorporated in earlier versions of Sonic Pi. And also it doesn't have to be on a Pi. The Sonic Pi I've got running on my Mac here is also running controlled by one of these programs, because I've got an iPad and an iPhone, and the iPad is actually going to drive this one here in the Pisound. My iPhone is going to, in a minute, drive Sonic Pi here, so you can see it in operation. And we'll perhaps start there. First of all, before we do that, let's just run through visually what the interface consists of. It consists of a series of 10 lines here, each of which has got a file name displayed in it. And these are files in a predetermined folder, which is written into the program. And in this case, there are 167 files on the SD card of this Pisound in a folder, and I can actually use the green button here to progress through these files. We reach the end there, that's numbers 161 to 167, and if I press the button on the other side here, this cyan button, we move backwards back towards the beginning, and then I go back to the beginning. So we can very quickly get to any one of these 167 files, and when we've got the one we want, we can simply press the field. I won't do it on one of the live ones because I don't want to actually have that running yet, but if I press this one, you can see that there is a button behind it which illuminates as I press it, and there are some little red leads you can probably just see showing up here and here and here, which are out at the moment, but when one of these files is playing, it will be illuminated too. So that's the transport mechanism, and the red button in the middle will stop Sonic Pi playing. If it's in the middle of one of these files, it will just stop it dead. And the two other ones which are shown in a purpley colour, the one on the left is enable audio in, and when I press that, it sets a flag so that when I start playing one of these files, it will automatically enable live audio for Sonic Pi and accept any audio which is coming in from the Mode P Pisound. And when I do that again, it will remove it. The one other feature it has is that normally if I just press one file and then another one, pressing the second one will stop the first one and start the second one. It's just obviates having to press the red button. But when enable audio is active, I can't do that, or at least I can do, but it will simply overlay the files. Now sometimes this is something you might want to do, and you could, because one of the nice features of Sonic Pi is that you can run one buffer and then you can run another buffer and they will overlay each other, provided you don't press the stop button in between. So that's what that does. The final button there, which you just press and it activates, it will clear out any samples which are stored in the memory of Sonic Pi, which will gradually mount up and can degrade to performance if you leave them lying around. And also I run the clear command in Sonic Pi, which just sort of helps clear out anything that might happen to be left lying around in it. And so if you start finding things are getting a bit funny and crackling a bit, then it's a good idea to stop. Press that, and often that can cure it. Okay, so that's the interface there. Let's now have a look at it running on here. And I've got on here, I hope, yes, there we are, the program jb.pi. In fact, it's jb2.pi because I've got a version 1 and 2 because they've got different folders for whether it's running on the Mac here or running on the Pisound. And that is followed by two parameters. There can actually be more than two, but two normally. The first one is the IP of the machine it's running on. Now I'm not actually running on 1234 because one of the later features I've added to the program is the ability for it automatically to pick up the IP address of the machine it's running on. And this I found useful on the Pisound because sometimes I've got this Pisound working, picking up its IP address from the Mode P one, which is acting as the access server, the access point. But equally, if I want to have a highly portable system without any MIDI, I can just have that Pisound running, in which case it becomes an access server and it will link to my iPhone, and in that case, and this enables me to automatically choose the right IP address there when I run this, because this is normally headless. There's no screens on it, and this access point is set up to run on a different address to this one. That's why that's necessary. So in this case, it will pick up the address, as you'll see in a minute, and TIP is the address of the touchscreen IP, which in this case is going to be my iPhone, which is on the same network as this access point here, and has been given the address 172.24.1.147. So if I come down here and I press that to start it, you'll see the program start up, and you'll see that it's actually picked up the address of the where the server is, which is going to be 172.24.1.132. That's actually the IP address of my Mac here, and we can just prove that if I come down here and look at Open Network Preferences. We can have a look at the Pisound M, and if we go into Advanced and into TCP/IP, you can see that that's the address that it's picked up. So it's actually picked up the right address without me telling it down here. So let's just cancel that and close that down again, if you don't need. And we're back here. Now, I'm going to use my iPhone, which you can't actually see, but I'm going to press the next button, That's this button here that we pressed before. You won't see anything, but you will see the effect of the program, that it's moved on to the next, and so we're now reading files 10 to 19. And if I press it again, it goes on and on and on. And I'll simply go up to a file somewhere near the end, and we'll start something playing that we can listen to on the Mac here, and we can see it's actually running. Let's just try this one here. No, that's a bit so. There's something suitable. This will do. You can see that Sonic Pi here has started playing. Don't see anything in here because this is coming using the command line interface, a little gem produced by Nick Johnson, which you can run with any Sonic Pi. It doesn't have to be version 3. You can send run file commands to it with the address of a file, and it will simply start playing it in Sonic Pi. I used it a lot because it's the run file command like this because it enables me to play files that are too long to fit in the buffer, and a lot of my files are very long. If I press the stop button on my iPhone, coming up now, 3, 2, 1, go, it stops Sonic Pi playing, and you can see that it's just stopped like that. And if we now come on and we can just try going to something, if I press the enable audio, you can see that it sets that audio flag. It's set to 1 down here, the message, and it will actually be acted on in the program. Press it again, it's set back to 0. And if I press the clear samples, that will actually appear like a run in Sonic Pi. And if I press it, you will see it started run 15 and it's now finished it, as it's carried out clearing any samples which are in Sonic Pi. So that just shows the sort of interaction between them. We'll come back to the program in more detail a bit later on. And in fact, we've now finished with this Sonic Pi here. I'm going to close it down just to make sure that we don't, you're not being fooled. It is actually Sonic Pi coming from the Pisound that we're going to listen to. We've also finished with this window here, so we'll close down the script which is running there, and we'll get rid of that, and we'll move this one over to the middle for the moment, and I'm going to in fact obscure the picture so that we get a slightly bigger screen, and this is logged on to the desktop of the Pisound. I do want to see it now. The Pisound on the right here, the one that's running Sonic Pi, that's given an IP address by the access point here, which is actually 172.24.189, and I've simply logged on with SSH to this so that we can look at the desktop, and that has got on it the JB Pi file, and we're simply going to have a look at that using the nano command here, jb.pi, and this is the script that we're talking about. And we're just going to very quickly skimper through it. I will be publishing it, so don't worry about trying to read it or copy it from here. It will be freely available. And as we move down this, if I can remember the commands to navigate this file, we start off by telling the program where the folder is which we're going to be looking at, the one which has got all the Sonic Pi files in it, and there it is. And the other piece of information it needs is the full address of where the Sonic_Pi command line interface is, which is going to interact with Sonic Pi. We import the module Python OSC, which is going to let me build an OSC message sender. This will let me send information back to the interface, such as the names of the files, to fill into these labels. These are actually labels which are on top of buttons, and also it's going to turn on and off the LEDs here depending upon which one of them which file has been selected to play. So that's why we need to send things back to Sonic Pi, and it's also going to run a server, and this is going to receive OSC messages from the touch screen, which when I press one of the buttons, and it's going to have a series of routines associated with it, which is going to dispatch. They're like handlers, so that each OSC message that's received and is understood will cause something to happen in this program. I'm not going to go through all the detail, but this is the little section that I referred to before, which actually works out the IP address of the machine it's running on, so that we can actually automatically supply that rather than having to read it from the --IP argument that we saw previously. But the next section actually deals with the, I come down a little bit, collecting the argument information when this is pushed, and you can see that there's mention here of the argument being added, which is going to add the touch IP address, the TIP one. Here it is here, the argument added TIP, and there's one up here which is going to add, looking for the argument for IP, which is the address that it's going to listen to, and so on. We'll go into the guts of that at the moment. Whoops, didn't need to do that. Didn't need to go into the guts of that at the moment. We'll just move further down the program, and I'm going to go right down to the end first of all to show that at the end we set up the Sonic Pi server, and that is going to run, and I just want to move up a bit more slowly. Let's just use a line time. That's better. We're starting off the server here, and these are the various dispatcher matching things. When we press the previous button, it's actually going to send an OSC message /JB/prev. I decided to call it that. I call the prefix for all these are called JB, which is short for Jukebox. And then there's the previous one, the next button, the stop button, and these F1 to F10 stands for the field behind which there is a button, and each of those buttons is going to send one of those messages depending on which one it is. Then there's an input for the audio in button, an input for the clear button. And this simply says that if you press the previous one, then use the function handle prev and send it the parameter p, which is actually going to be the 1 if it's pressed or 0 if it isn't. And similarly for the next button, for the stop button, and for all the others. If we move up the program a little bit, we can see one of those handlers. Here, first of all, is the handler for the clear button being pressed. Now it says if CL is equal to 1, that's the parameter which is fed in. It'll be 1 if we press the button, it'll be 0 if we don't. We only want to do it once. As we press the button, it's going to print clearing, which we saw previously when we were looking at the output of this script. And then it's going to send the command to Sonic Pi clear semicolon sample free all. And those are the two commands I talked about clearing up the memory and freeing the sample memory in Sonic Pi. And that is sent as a system command. C is actually got in it the address of the command line Sonic_Pi, and then it's going to send the command run code, and it's then going to send that command. So that's how that works. All of the others work very similarly. The audio in sets the flag, audio flag to 1 or 0 depending on when it's pressed. If it's not pressed, it's also going to switch off the live input, and the way it's going to do that is to send to Sonic Pi the code live audio :sin, :stop. Well, live audio :sin is the name I gave to the live audio when I started up, and putting a parameter :stop after that will simply shut it down. And we'll see how it started a bit later up. We go to the previous button, button 10. Now what that does is it, first of all, will only respond if n is equal to 1. N, the argument there, is when the button is pressed. it first of all checks to see whether there's a valid file there. In this case, there wouldn't be, because start would point to the first of those files there, and start plus 9 will point up here, and it says, is that greater than the maximum number of files? Well, it is, because that's the maximum number there, and therefore we're not going to actually do anything, so it would actually ignore this. But assuming there was a file there, and that would be the case if we move back 10, like that, in this case it would pay the file sp-rg-rf. You may see rf at the end of a lot of my files, by the way. It just reminds me that I need to use run file for those, because they're too long to work otherwise. Right, so where were we? Yes. So it's then going to say, is the audio flag 0? If it is, it's going to send a stop command to stop any previous file playing. And that means that I can just go around pressing one button, then another, without pressing stop in between, if they are normal files. I can't do that if audio live is on, because the way we use audio live, you can see here, if the flag is 1, we send the system a command sonic underscore pi run code, and the code which starts up the sound is this. Let's just make that a bit wider so we can see the whole line. There we are. With FX :compressor amp2 do live audio :sin. Remember, we referred to the sin before when we were stopping it. End. And that's the code that you put in a program. Now, rather than put it into all of my MIDI programs, I simply run it as code, and provided I don't run a stop command before I run the MIDI file, the live audio will be active while this is running. It's a nice feature of Sonic Pi. You can run as many buffers and things with code in as you like, provided you don't press stop. They will all overlay on top of each other and will work. So that's that. Excuse the cold. And as we move further up, we've simply got more buttons which are the same as that. They're all very, oops, I don't want to change that. Then press the wrong button, it should be control. There we are, going up. And you can see that they're all very, very similar. There's the stop one, which is just sends a stop command. It also sends a command MIDI sound off. That just means that if we're playing a MIDI file, we stop it mid-note, it might leave a note hanging and it's not being turned off. And so it's just keep on running on the synth there. So sending it MIDI sound off will make sure that it does stop. And it also clears all of the LEDs that are on, so that whichever one was on, they're all off now, nothing else is playing. So I think that's probably enough about that program. Let's just exit that. We won't save any modifications, it was fine as it was. And just very briefly, I'll say something about how I started the program running automatically, because I don't have any screen or keyboard normally connected to the Sonic Pi box here. You simply turn it on and it starts up running Sonic Pi. Well, the first bit is fairly easy. What we do is let's just clear that screen and it's back to the top. And what I do is I use a cron entry, which simply, when we boot the machine, runs a script in home pi desktop start spsh. And if we go and have a look at that, cat start sp.sh, there it is. It's only got one command in it really, which is this one here, and it uses an X virtual frame buffer. This is a way of simulating the fact that you need to have a monitor for Sonic Pi to work for all the GUI to set up on. You give it a virtual one, and then you use the xvfb run command, and this is running Sonic Pi, and the binary for that is actually located in my Pi home directory, because I'm running one that I built myself rather than the release version. And incidentally, this is Sonic Pi 3 running on Jessie rather than on Scratch, although I could equally have used Scratch, but I happen to have a Jessie disk in here. And because there's quite a lot of stuff produced when Sonic Pi runs, we're running Headless, we're not really interested in it, so I simply send any output that produces, text output, to null, so it's ignored. Then the ampersand, that just means that it's left going and that script executes very quickly. Now it takes Sonic Pi about a minute to run up, and so how do you know that it's ready? Well, the answer is you get Sonic Pi to tell you, because there's another very nice feature of Sonic Pi which you may not be aware of, and that is that in your home directory you will have a hidden folder called Sonic underscore Pi, dot Sonic, dot Sonic dash Pi, and that actually holds the logs for Sonic Pi. They're in there. There's quite a number of them. They're very useful when things go wrong, so you can see what the problem is. And also, it holds a store which has got inside it all of the workspaces which are saved when you quit Sonic Pi, and they come back when you start up again. And so that's another useful thing to be aware of. And then also, and this is the one that we're actually going to use here, there is a file called init.rb, and this is rather like a Sonic Pi standard file that you would save, and it is automatically run when Sonic Pi first starts up. And inside that, I have put a system command here which says run the JB Pi script with these values. They may actually be overwritten if I'm running on a different thing, though those are actually the right values for this particular setup we've got at the moment. And again, we don't want to look at the output that the script produces, which we saw on the previous version, which we were running with the Sonic Pi on the Mac, because it all happens, and we can see on the touch screen what's happening there, and we can hear from Sonic Pi that it's working there. And then we play a note for 2 seconds, and when I hear that I say, Sonic Pi's ready to go. So that's the setup there, and if we quit that, we can, in fact no, I haven't done it to quit because I'm actually running. There is actually one other feature which I won't go into in great detail, but I've also set it up so that when I want to switch from using the right-hand Pi box here running with the left-hand one and getting its IP address from here, I can press the black button here 3 times and can turn this into an access point on a different IP address to that, and it will, of course, that will clobber the program which is running because we've changed IP addresses. So if I then press the black button once, it will cause the JB Pi program to restart, and this is why I added the auto IP bit. It will realize that it's got a different IP address, and it will also use that different IP address to send stuff to a different terminal address for my iPhone, which can then connect to that access point. And that gives me a very minimal system of just one Pisound box, one iPhone, one set of headphones, and a portable battery. And the whole lot could just sit in my pocket and I can listen to Sonic Pi on the move. But I'm not going to demonstrate that just now. So enough talking, let's get some action now. And we're simply going to get rid of that, which we're not really interested in. And we'll move this over a little bit, because I want now to have a look in more detail at this once we get going. But we're going, first of all, just to run through some programs and see that this actually works. I'm going to pick up my iPad and we'll start off by playing something like Sliding Arpeggios by pressing the button. And there it goes. You can adjust the volume by the volume control on the Pisound box. Oh, enough of that, let's do something else. Beatles' favourite. Let's nice thing about this is that you can just see the genre of Sonic Pi very quickly by just flicking around. Something else. And again. All of those pieces so far could equally be played on Sonic Pi 2, and this Jukebox would work quite happily with that. But we want to look at some of the new features in Sonic Pi, particularly the use of MIDI. So I'm going to move back down the list until I can find a suitable MIDI file to use. Again, back to the C's, I think, and we'll start off with this Clavier Concerto. Now, up here, we've got the website, which lets me change, if I want to, the connections that we've got here. Let's just go to here, and I'm going to choose for this one that particular setup. Yes, we will. We'll just go back there, and that's coming up there. And we've now got two synthesizers. The top one here, if I just click down there, you can see is set to a harpsichord. And if we go back here and we make that a bit bigger so you can see a bit more, and we look at the bottom one, that is set to strings. And if we look at the wiring, if we just zoom in again, that is signifying the MIDI inputs coming to both of those in parallel, and they've both got stereo outputs going to the left and right output channels there. And just to remind you of what's happening over here, there's the MIDI input coming from, or MIDI output coming from the Sonic Pi and is going into here, that's that point there. And then the outputs here are coming down this black cable and back in to the sound input here. And we're going to turn on live audio by simply clicking on there. So, also not on there, I'm going to do it for real on here. There we are. And it's turned on. Remember, that's just a picture or video of what my iPad is doing. And now we can press this Clavier Concerto MIDI RF file and it will start playing. Just adjust the levels a bit. And to prove that it's coming from here, we'll just turn these off. Turn the synths off so you can't hear anything. I can see some red LEDs flashing on the Pisound boxes. You can't actually see them because you haven't. It's not in the video. But if I turn this on again, we can also, if we want, on the fly, change this, and I can actually do this by pressing a button on the black button on the Mode P Pi, because I can actually press, say, let's do 4 times, 1, 2, 3, 4. And it's going to choose a different setup. It's been pre-done. Oh, that was not a very good one to choose. There's nothing in that one. Let's just press 2, see what that does. Oh dear, it's not picking these up. There we are, let's pick that one up. That's now changed to playing an organ with it. So these are set up in here, in fact, pre-done ones are here, and it should be, let's say, 3 clicks. 1, 2, 3, 1, 2, 3. That should switch to that third one. Switch to there. So on. So we'll stop that playing. Well, in fact, no, we won't. I'm going to play something else and just see what happens. We're a mess because remember I said if the enabled audio was on, then it wouldn't. You couldn't just go from one to the other. We have to actually stop first and then start playing like that, and then it's quite happy. Let's do another MIDI one. Let's try and do this one here. Change to something more appropriate for this one. Some brass. Stop that playing. We'll enable the audio input and we'll play this. Swiss number. Into the volume there, just changing the velocity of the MIDI signal. And it goes loud again at the end. Change. Trombones only. Play it again. We can actually change on the fly while these are playing what the synth is. There we are. So you can see that you can have a great deal of fun with this. I hope that's given you an impression of what we can actually do with this. I could go on talking about this for hours, but that's probably enough to whet your appetite. Perhaps just press another couple nice ones. This is one of my grandson's favourites. Out nicely and stop it. Oops. Yes, yeah, didn't quite stop. And we'll finish, perhaps just clear out anything there. This taxes Sonic Pi quite a lot. Ski Sunday. So run on Sonic Pi 2. I just faded it out nicely using the volume control on the Pisound. I hope that gives you a good impression of what you can do. This Jukebox interface, which works very nicely, and the Pisound boards, which are great pieces of kit. Hope you've enjoyed watching the video. This will all be published, the software, on my website blog before too long. Thanks for watching.